Good evening, everyone. Yes, sure thing. So I'll do some of the formula reviews. Okay, let me see. It's not detecting. Can you guys hear me? Oh, I think my speaker wasn't on that whole time. I'm so sorry. I just saw. So can we find midpoint using two endpoints? Yes. Find midpoint using endpoints. So if you're just joining us now, all I went over were the three formulas. Where was it? Midpoint, distance, and slope. So that's all I did so far. Perimeter area, yep. Rules about planes, perimeter area. Okay, so the next one is number 55 on the packet. And let me find that packet. Number 55, is that the one with the trapezoid? Let's see, I'm gonna triple check. Yes, okay. So number 55 in the packet is a picture of a trapezoid. It tells it's an isosceles trapezoid, so even better. So trapezoid, because one pair of opposite sides is parallel, so I drew it in right now. Isosceles, because two sides are equal. So we know in a trapezoid, because of the two sides are parallel, we can use same side interior angles from way back when, from chapter 3. So I think we can find angle 3 first or angle 1 first. So if I redraw this and use prior knowledge, so here's same side interior angles, that means those two add up to 180 degrees. So in other words, angle 3 is whatever the leftover is from 180. So 180 minus 109 is 72 degrees because they're same side interior. So that's one. Okay. Then for isosceles, remember how two angles are congruent. Therefore, the base angles, we call them, because it's touching the same base, those are automatically the same. So without no math calculation, angle 1 is 109. Automatic, because it's isosceles. Okay, and automatically angle 2 is going to be the same as angle 3 because they're touching the same base. So no math, that one is automatically 72 degrees. And you could always double check your math. You can say, all right, all of these 4 angles should add up to 360. And, oh, did I write the wrong number? Uh-oh. Double check. Isn't it 71? Oh, it is 71. Thank you. I don't know where I got 72. Good call. Thank you. 71 degrees. So measure of angle 2 is 71. Measure of angle 3 is 71. And measure of angle 1 is 109. Thanks, Sydney. You're the one who asked too. All right, logic, proofs. Okay. And let's see. Naming parallel. Naming quadrilaterals. All right, so the next one I'll talk about is proofs and angle side angle difference. Okay, so for your final, let me just kind of give you an overview. It's split up 200 total points, so it acts kind of like 2 tests. Okay, it acts like 2 tests, but it's split up 50 points and 150 points. If you're period 246, then you're Thursday. And if you're period 135, then you're Friday. Okay, but the 50-pointer one is where there will be some proofs, including triangle and logic and indirect. So everyone asked those already. There will be some matching. And it'll look similar to your final review, the first page, first and second, front and back side. There'll be some truth tables, circuits, and I think that's about it. Then the 150-point one, that one is multiple choice, and that will look like the remaining of your packet. So 4 choices per problem, A, B, C, or D, and you just bubble into a Scantron, and that's it. What if a person doesn't finish on time? Then we grade what you have. So you always kind of like, look at the clock here and there, and if you have literally 5 minutes left, my advice is you just, or even 1 minute left, just bubble in anything just to at least get something, because there's no harm in guessing. So word of advice, if you're down to 2 minutes and you have to, the bell's going to ring, just start bubbling in. If there's 50 questions on multiple choice, and let's say approximately, I want to say maybe 10 to 20 questions on the other one, that's like 60 questions. So just a quick, if there's 50 multiple choice questions plus, 10 to 15 or so, like proof slash etc. And you have what, 90 minutes or so? Just estimated, you don't want to spend more than 1.5 minute per problem. Some it's going to be like fast, like 5 seconds, and some will take maybe a minute, 2 minutes. So it'll balance out. But yeah, so 100 questions, not quite 50 fill in. Like there's not 50 questions, Sarah, but it's 200 points, Kyler. 200 points, not questions. 200 points total. So the 50 questions will add up to 150 points, so 3 points per problem. And the 10 to 15 questions will add up to 50 points or so. So maybe like, 3 to 5 points per question or something like that, okay? All right, so I'm going to go back to talking about proofs. So make sure you know the difference between angle side angle and side angle side. That's a great question. So if you have something like this and nothing's parallel or anything like that, but we can automatically, without any given, put a tick mark in the middle, okay? Just FYI. And another one, if you have two triangles, something like this, automatically, no given, you can mark these. The first one is reflexive property. The second one is vertical angle theorem. So those are automatic, what you could fill in extra without any given provided, just based off of that picture. So now let me label a couple more stuff. So let's say from the given, these were labeled. I'm just pretending, okay? Like that's there. No parallel, okay? We don't know that. All we know is maybe these items. So from this picture, the top picture, if you look at it and if you break it apart, you notice there's a tick mark, an angle mark, and a tick mark. So if you count this is a side, and the middle is the angle, and then this other one is a side. That means you have to have two S's. So it's not angle side, or it's not angle side angle. Like it can't be those because there's no two angles labeled. So you're just hoping in this scenario that the actual angle is in between the two marked sides, and it is. So that's how it's side angle side for this case. And it's the same thing for this triangle. It's also side and another side, but there's an angle in between the marked sides, therefore it's side angle side. Since they're the same, these two triangles are congruent in that manner. Yes. Let me label this other one. So the second picture right here, okay? Let's say these were marked from given or whatever, and let's say these two are marked. Let's say it's a midpoint, or bisected. So this time it's different because we have an angle, another angle, and we have a a side that's in between. So that means this will be angle side angle and not angle angle side. The side is in between the two marked sides, therefore it has to be angle side angle. Same thing for the other triangle. It matches perfectly. The side is in between the two marked angles, therefore it's angle side angle. Here's a picture where it'll be angle angle side compared to compared to angle side angle. So the reason why, so I already said, okay, this is an angle that's marked, and then I have a side that's marked. So you're like, oh, I have two choices. It's either this one or this one. And so I know based off of the yellow angles, the side is not in between. This gray side is just touching one angle. Therefore, it is angle side angle. I'm sorry, angle side, not the other way around, okay? And same thing for the other picture. If you look at your two angles that are marked, I'm going to color in gray again. This is the mark side, and it's only touching one marked angle, so it's angle side angle. Okay, so basically your proofs, so let's get into the proofs. This is number one in the very front of your page of your packet, and it's going to be similar to this, so that's why I'm doing this again. So you've seen this before on a test as well. So the only thing that was given in this situation was H is midpoint of AS. So we have to put a tick mark pretty soon, given. And there was one more given, LA is congruent to LS. So right after you read the given and write it in there, you should say, let me mark this part. Let's mark H is the midpoint of AS. So I have to mark that red segment. Okay, so then that's done. Then from here, I have to convert that sentence to like a congruent symbol. So I marked it on my picture. It has to be in my statement side of the proof. So AH is now equal to SH, or congruent. Okay, so I have literally one tick mark each in the picture, in the triangle, and I have it written here. Yes, I will, Ben. Next question, or next part is LA. I'm going to put tick marks there, and I have that already written down. That was given. Then lastly, I have to try to figure out one more tick mark. And I can't say 1 and 2 are congruent. That's jumping to conclusions. I could go different routes. I can either say LH is congruent to LH, because that's reflexive property. Or some people might say A and S are congruent. Yeah, so you can do SAS or SSS, okay? Let's see, we need circumference answers in terms of pi. I'm not sure, Jay. Either just always read the directions. So I'll come back to that question, circumference in pi or round. So it will say either round or keep it in terms of pi. And you'll see the multiple choice, okay? So I'm going to go back to this proof. Sorry, guys. So LH is congruent to LH. That's one route that you can go, and you'll call it, oh, sorry, number 2, I skipped it. That's definition of midpoint. I got it from the first sentence. So that's where it came from. Number 3 is reflexive, property of congruence. And so look at how my picture has 3 tick marks. And my statements have 3 congruency statements, like 1 congruent, 2 congruent, 3 congruent. So we're ready to say the triangles are congruent. You always need 3 things before, 3 congruent before you see triangles are congruent. So it doesn't matter the order, but AHL, right, or AHL, is now we have to be picky. Okay, A matches with S. H matches with H. And L matches with L. So that's by side, 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 like Kyle said. And from here, number 5, we can say, we have to choose wisely. Okay, so number 6 says LH bisects 1 and 2. So you would, at this point, want to read the last sentence before jumping to conclusions. So from here, I want to mark 1 and 2 now. I want to, because that'll show that LH did cut it in half. So number 5, I have to choose super wisely. Number 5 is pretty important. And that's CPCTC, corresponding parts of congruent triangles are congruent. And then I can finally say LH bisects, and that's definition of angle bisector. So this could be done differently. So I could change step 3, okay? I don't have to do LH equals LH. I don't have to. I could have done angle A and S, and that'll change this to be SAS. Okay, and how come? So I wonder if I could erase this. Again, I could change step 3. And step 3 could be, oops, what happened? Angle A is congruent to angle S. So step 3 could be angle A congruent to angle S because of isosceles triangle theorem. The two sides are congruent on the outside, so the two angles are congruent. That could modify it. Could it be HL? Not necessarily. We can't jump to conclusions because we don't know if angle H is 90. I mean, later we'll be able to, but we can't do it in the very beginning, correct? There's no definitive right angle. It's not a for sure. But if there was a for sure right angle, then yeah, we could definitely have used HL, okay? Let me kind of recap. So it goes sequential by the most angles on one side. So Sydney, yes. So if I have another one, going back to side angle side versus angle side angle, if I have these as my tick marks, you look at one picture at a time and you say, okay, this is a side, right? This is a side, and then the one in the little curve is the angle. So you say, I know that I'm going to have two S's. My two possible choices are SSA, which never is a guarantee, so that's probably out of the picture, and versus SAS. Those are my two possibilities. So I just have to find out where the angle is, what's right in between the two sides. So therefore, this is the answer. If I draw another one, I had only these and only these marked. I have to mark one more side, and that's the shared side. That's reflexive property of congruence. This case is no good. I have two sides, okay, but I have the angle in the wrong spot. So in this case, I have a side, and an angle touching only one side. That therefore this is representative of that picture. And remember, this doesn't guarantee triangle congruency. Therefore, we don't know if they're congruent. Not sure. So not congruent, guaranteed. Okay. All right. Let's do indirect proofs. Then we'll do finding midpoint, and we'll do some logic and all that good stuff. Graphing orthocenter, circumcenter. You don't have to physically graph it, Sarah S., if you're still here, but you might have to recognize it. So for instance, if I had a picture, but if it wasn't in the packet, I highly doubt it. Okay, Sarah. But orthocenter would be at the right angle because it's based from where the altitudes are. So that's the orthocenter. And then if it's a circumcenter, that's where the perpendicular bisectors are. So that's on the hypotenuse. So here's the bisector of this segment, and then make it perpendicular, and then continue it. All right, then make another bisector, so here, and then make it perpendicular, and then continue it. Okay, that drawing is terrible, but they should have intersected on the hypotenuse, and that's your circumcenter. But you don't physically have to graph it, okay? You might just have to recognize it. All right, let's see. Indirect proofs. So there was one sample on your packet, and it was regarding the triangle ABC. Here's the rule of thumb. Depending on which teacher you had, but for Tira, I had a 4-step model. And this is the time where we didn't have to do 2 columns. We could, but we don't have to. So I'm going to do number 4 from the packet using columns and using no columns. I'm going to just write sentences. The important thing about indirect proof is that we have to assume temporarily the opposite of the proof. So I have to read what my proof is. My proof says on your packet, angle A is not congruent to angle B. That's what we want to prove, but we're not proving it directly. We're doing the opposite, and it's going to fail. So what we're going to write in is angle A is actually equal to B. Okay, so it's directly opposite. Right, and we're trying to get a contradiction. The other given part to this question was triangle ABC exists and CA is not the same as CB. CA is smaller, less than. So step 2, we have to use this information, this new addition, and we draw a picture on the side and say, all right, here's A, here's B, here's C. I didn't draw it right, sorry. And A and B are congruent. All right, we got to believe it. So that is going to make it isosceles. So the angle B across from it is AC. That has a tick mark. And angle A across from it is BC. That has a tick mark. So step 2, we use step 1. We use that information. So if angle A is congruent to angle B, then we can conclude, we can infer more information that BC is equal to AC, and that's by converse of isosceles triangle theorem. It's converse because of the order. Angles congruent first, then the sides are congruent. That's converse. If its sides are congruent first, then automatically in our head we're like, oh, it's isosceles. Then we can say angles are congruent. So order matters, okay? Now, I already found the contradiction. I don't know if you guys did. The contradiction is what we just wrote down. BC is equal to AC, but that goes against this right here. What? How can you be equal and how can you be smaller? Like, that doesn't work. So, let's see. At step 3, we'll say BC equals AC contradicts the given CA is less than CB. So how can you be equal versus one time is smaller? Like, nuh-uh, that doesn't work. So the word that we're looking for is contradicts. Then that means this green opposite of proof, it failed. So we're going to say angle A and is equal to angle B is false. It didn't work. It gave us a contradiction. So thus, the complete opposite, which is what we wanted to prove, is true. Right? It's one or the other. So if one is false, then the other is true. And that's what we're trying to get at. And so we didn't prove this directly at all. We just proved the opposite failed. Therefore, the original had to be true. Okay? Yes. No constructions, Cassie. Okay. All right. So then that's one example of indirect proof. And then the 2-column proof would have been similar, where we would have done angle A is congruent to angle B, and we say assume temp opposite of proof. This is if you wanted to do in a 2-column, but most likely it'll be the sentence structure that I did. Then I'll say, I need a picture. So always draw a picture. Then I can say AC is equal to BC by converse of ITT. Same exact thing, just doing it in 2-column. And then here we will write the given, which was CA is less than BC, given. And then step 4, we'll say angle A can't be equal to angle B because contradiction of step 3 and 4. And that's the quick way or the 2-column proof way. Okay? All right. So the next one, let's talk about midpoint, and after that will be rules about planes, and we'll go from there. Okay. And if you have a question that I didn't write on the middle, please jot it down again. Okay. Sorry, I missed it. So let's say find a midpoint of 2, -5, and 3, negative 10 or something. I might get decimal, sorry, okay? So you could imagine, without doing formula, you could imagine what's the number between 2 and 3? Well, it's not a whole number, right? It's in the middle of 2 and 3. So you can say, oh, the middle is 2.5. And you're like, oh, how'd you get that? So if you don't like it that way, you can do the math. You can do 2 plus 3 divided by 2, and you'll get 5 divided by 2. Then you'll try to find the midpoint of negative 5 and 10. So if you're a visual person, here's, negative 10, and here's negative 5. And you're like, where's the middle? Okay, the middle is go back 1, and then it's right in the middle. Right here, that's a decimal. So that's negative 7.5. Or you're like, how'd you get that? You can do negative 5 plus negative 10 divided by 2. You're finding the average. You're finding the middle. So that's 2 separate ways of doing it. You can look at the numbers that's given to you and say, visually, where does it lie on the number line? Here's 2, here's 3, the middle is 2.5. Okay? There's a harder one. If you're given one midpoint, not harder, but just more thinking, 5, 10, and then you're given an endpoint, just one endpoint, is something like 7, negative 2. Find the other endpoint. And you could do this algebraically, but I have a different technique. So we have to think, here's 5, here's 7. This is already the midpoint, so we're trying to figure out this endpoint right here. And that number is 2 spaces away from 5, so then that means this is 3. So if you look at these are 2 spaces away from each other. This is just a shortcut. If you're given the midpoint, if you're given one endpoint, find the other one. So you could do the same for negative 2. 10 is in the middle. Negative 2 is all the way out here. And so we need to find this endpoint. So we have to say, well, the spaces amount between negative 2 and 12 is, negative 2 and 10 is 12 spaces. So then that means there's 12 spaces between 10 and the other number. This number has to be, whatchamacallit, 22. And you could check your work. You can say, all right, let's do the math. Is negative 2 plus 22 divided by 2 equal to 10? Yes. Is 7 plus 3, that's 10, divided by 2 equal to 5? Yeah. So different ways, right? This is more visual. It doesn't include algebra, which is pretty cool. Sometimes, we got to figure out different ways to help us out. Rules of planes is the next topic. Rules of planes. I see some people typing. Okay. Planes. So, there's parallel planes. There's, let's see. So within parallel planes, let's say we have like a box, right? Or something. So let's say a piece of paper is up here and another piece of paper is up here. They'll never touch. They'll never collide. Okay. And then if I draw like a box, right? So we have a box. And now if we have like skew lines, the term skew means they are not in the same plane. They're non-coplanar. Okay, and then they will never touch, never intersect. So they're not parallel, basically. So, for instance, this line that's like coming towards us, right? And then this other one right here, that's not considered skew because they touched. So that's a bad example. Okay, then how about this bar up here? This goes up and down forever. And then think this is 3D, right, coming at us. This one is coming towards us. These two lines, the green and the blue, will never touch, so that's considered skew lines. Let me give you more examples of skew lines. Let me use green. So the blue one, and this also horizontal one, will never ever touch, and you can't create a plane. Like if you try to draw like a diagonal plane, it won't happen. Like both of these won't be on the same one. This blue one is going to go through this plane that I drew. So that's why it's non-coplanar. Okay. So that's one item. Let me see what else is there about planes. Oh, you have your good old plane. Let me look at what is the intersection? So, okay, so collinear points, that's on number 1 on your topic of packet. Collinear points are on the same line. On the same line. So what I drew, ABC, those are coplanar. But would A, B, C, D all together, would that be collinear? Is that true? Nope, it is not, right? This oddball made it non-collinear, exactly. So if I take this away, yes, they're collinear, right? Now this is collinear. But if I include D, then it's now non-collinear. So one thing can mess it up. Yes. So A, B, C, D is non-collinear. That D, that point D made it messed up. Okay, that's number 1 on your homework packet. So if you look at your packet, there's like many lines going through the plane or on the plane. GM is on the plane, ET is on the plane. So ERT, those are all collinear. Also another set is GRM. Those are another collinear. And also there was one line that goes through the paper, and that's ORY. So there's 3 separate sets. 1, 2, 3 that are collinear. Okay, yeah. Intersection of the planes. Oh, so planes, you could either use 3 points, that's the bare minimum to make a plane, or 4 points. So you might see, plane, there's A, B, C, D. You might just see A, C, D. That still represents this top portion because it includes 3 out of the 4 points. Okay, so that whole top portion is A, C, D. Or I could call the whole top B, C, D. Oops, no commas. Or I could make it super obvious and say it's A, B, C, D. So you could have 3 points or 4 points, okay? 3 is the bare minimum. So for the packet, it said, what's the intersection? This doesn't answer that question, but similar is if you have 2 planes, there's something that's touching the 2 planes, that's connecting it, that piece. And this piece is this section right here, and that will be called the line. So the line intersects 2 planes. It's the glue, right? Think about the glue piece, right? So the homework or the packet is, for this case, is CB. Nice, Kyle. 46, sure thing. All right, so let me continue on to another question. The other question was perimeter and area. So perimeter is, depending on your shape, if you have this weird wonky shape that was on your packet, you have to sometimes write in more information. So knowing that this part is 2, that means this part is also 2. You've got to write that in yourself. And this is 4, and everything, they're all right angles. That's what it said. So we have to draw that in ourselves. So that means if this side is 4, the other side's 4. And, oh, we need to figure out this little tiny piece right here. And that tiny piece is whatever 2 plus blank plus 2 equals to 7. So the leftover piece is 3. So now 2 plus 3 plus 2 is equal to 7. So now perimeter, you just add all sides. So 7 plus 4 plus 2 plus 2 plus 3 plus 2 plus 2 plus 4. So I just kind of followed in that motion. That would be perimeter. And then area is a different question. Area is base times height. So let's see. The area is interpreted different ways. So some people see it as a big rectangle minus a tiny rectangle that was right here. So they can subtract. So it'll be 4 times 7, that's 28, minus this tiny piece right here that's missing, that's 3 times 2. So 28 minus 6 will be 22, final answer, 22 square units. Another way of looking at it is cutting it up in different parts. So, oh, some parts got deleted, sorry. Let's redo, this is 2. Another way of looking at it is cutting into 3 sections. So you have 4 by 2, you have 2 by 3, and you have 4 by 2 again. And there's one other way you could look at it. So that should add up to the same number. You could cut it up into 3 pieces again. You'll have 2 by 7, a 2 by 2, and a 2 by 2. And that will give you the same, what was it, 22? I already forgot. 14 plus 8 is 22. Yep. Okay, so perimeter versus area. To answer someone's question about circumference, so it looks like number 9 on the packet is circumference, and it says leave in pi. So if it says leave in pi, yeah, just leave it, and it'll be multiple choice, so you're good to go. The radius was 4.1. The formula is 2 pi r. So from there, it would be whatever 2 times 4.1 is. I think that's 8.2, and then pi, and that's your result, square units. Okay. Oh, thank you. Yes, thanks for answering Sophia's question. Cool. All right, then logic proofs, naming quadrilaterals, and then number 46. But I think Jay is answering, so yeah, well said, well said. So I think 46, let me kind of go out of order just to kind of go through what Jay is saying. So to make a triangle, we're saying 5, 11, and what could this be, right? So the trick is, if you're trying to find the range of numbers to create a triangle, you subtract the numbers, and then you add the numbers, just like Jay said. And so if you subtract the numbers, you'll get 6, and if you add the numbers, you'll get 16. And if this is 7, right? So let's say in between 6 and 16, this triangle works. 5, 8, 11 works. 5, 9, 11 works, right? So all of these work until it gets to 15 or so. Yes, all right. Let's see, the next one is logic proofs. Okay, so logic proofs, you have to remember a few things. So you need to know what modus ponens is. And modus ponens is if you have arrows. If you have this as your given, and then the first part, then your answer, hold on. Yes, your answer is the second part. That's modus ponens. Modus tollens is backwards, where you're given not the last, oops, I wrote that wrong, not the last part, so not B, and then the result is not A. So that's modus tollens. That's the big difference. So you have to have arrows. You have to have another given, 2 givens. disjunctive syllogism, you have to recognize that disjunctive means or. So you're looking for this symbol, and then you have to say not the left side. So you have a choice. It's A or B. You got to choose one. And then later someone forcefully tells you, nope, okay, you can't choose A. So then you're left with the other choice, like just actually no choice, like that's your answer. And so that's disjunctive syllogism. Okay, so it has to be an or, and you have to say, sorry, you can't choose the first one, so it has to be the second one. Okay, another popular one is simplification. That one's cool. If you have an and situation, automatically you just get to take the left side because it's and, so both work. It's A and B, so you could just choose A. Let's say you want B. So then let's say you were given A and B and then given, but you want your answer to be B. Well, you need a little side step right here. You would have to switcheroo. It's called commutative property. Commutative property only works for and ors. Okay, the if then, the arrows don't work. And then now this will be simplification. Boom. Okay, is there a full-on one? There's a few. Oh, there's one logic one. This is from the packet, number 9. So here's given. I'm going to write it out actually here right away. So look at that. I already know what to do with that one because that is an and. Already in my mind, it just popped up. I could just choose the left side. However, there's one more given, and I don't think I want to use P. I don't think P is useful. So if, this is wrong, if I did P, because that's simplification, yes, that's true, but that's not helpful for number 2. Like that's terrible. Like there's no P in there. So I don't want to use P right away. So instead, I'm going to look at number 1 and say, you know what? If I only could get Q out of it, then it'll be so useful. So that means I'm going to switch it because of the ands, you can switch. So this is simplification from step 1. So usually when you use a step, you don't use it anymore. It's gone, okay? And then now I could use step 2 and 3 combined. Actually, I stepped too far ahead. Now I can say, commutative, I'm so sorry. Now I could use simplification. I could grab the left side. That's step 3. So I could essentially cross this out. Don't cross it out on your paper, but I'm just saying we don't need those anymore. We're kind of done with those. So then now focus your eyes on step 2 and 4. That's either modus ponens or modus tollens, and it's ponens because you're given the first part. So the result is the last part, the conclusion. So that's modus ponens. Right on. That's 2 and 4. So I am no longer going to use step 2 or step 4. I'm just crossing it out to say it's done. And then the end goal is very similar to number 5. It just, I don't want to say it distributed because that's incorrect because these symbols switched. So this is De Morgan's. Yeah. And if you look at your result side, the right-hand side, every single step got used. 1, 3, 2, 4, and 5. It doesn't have to be in order, but they all got used up. And therefore, we're done for that one. Okay? Logic. So you got to know your stuff. I hope that your teacher in the previous time when you learned it gave you a handout or you wrote notes on it. So hopefully you got that. Okay? All right, then let me see. The next question is naming quadrilaterals, and I think that's the last question we have, unless there's more. Is it okay if I put commutative and simplification? Yeah, absolutely. Yep. So step 1, 2, and 3 could be interchanged for sure. Correct, Kaylee. So I could have done commutative first instead of the given and then simplification. That would have made a little bit more sense. Yeah, I should have done that. So Kaylee, good looking out. All right, quadrilaterals. So quadrilaterals have 4 sides, and one case it could be is a parallelogram. And that's if opposite sides are parallel. Or it could be a kite where nothing is parallel, but the 2 neighbors are congruent and another 2 neighbors are congruent. A third figure could be a trapezoid. That one does have parallel, but only one pair, not 2. So within even parallelogram, you could branch off and you could call them more shapes. So you have your good old rhombus, you have your rectangle, and the most special square. The rhombus, all sides have to be equal, right? But not all angles. Rectangle, all angles gotta be 90. And the good old square is where everything put together and tick, 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 tick all over the place. So we got 1, 2, 3, 4, 5, 6 different quadrilateral shapes. Within the trapezoid, you could have isosceles trapezoid or just, I don't know, normal trapezoid. Okay, so that's to quickly name them. Some features of like rhombus versus rectangle. So rhombus, what's really, really helpful is yes, you know all sides are equal, and this extra addition in the middle, they all create 90 degrees. And that means all these parts are, all these triangles inside are congruent. So I hope you see 4 congruent triangles by either side, 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 or by side, angle, side. And that leads to me to say that these corner angles got bisected as well. They're the same. So if this is 50, this has to be 50. If it's a rhombus, this has to be 50. This has to be 50 because these 2 triangles are the same. So it has to be. And then same goes for here. These have to be the same because these 2 triangles are the same, right? So then these angles will be the leftover of 100. This is 100 over here. The leftover of 100 is 80, and then you split it up in half. Or some people look at one tiny triangle and they say, oh yeah, they all add up to 180. So you can do it in different ways, okay? Let's see. You guys okay? So let me do a quick run through before time is up. So just going in order from chapter 1 to chapter 6. So chapter 1, you need to know these vocab. Collinear, so all on the same line. Coplanar, all on the same plane. It could include lines too. Then there's the intersection, opposite rays. So opposite ray is here and here. So A, B, C. So A, B, nope. B, A and B, C. They have to start with the same letter. Let me see. Will there be orthocenter, in-center, making angle bisectors, protractors. No, there won't be. You won't need to graph it, and you won't need to use protractors or compasses. So no to that. But there will be in-center and orthocenter stuff. I think if you look at your packet, your yellow, your review packet, it should be, where did it go? Number 40 to 42. So 40 to 42, okay? Continuing chapter 1, let me see. You need to know how to find midpoint. If you have like not even a coordinate, like 3x plus 2 versus 5x minus 4 or something, right? You have to find the midpoint. So you got to calculate x. So they're equal to each other. Solve for x, then plug it back in, okay? Need to know angle bisector. So if you have an angle bisector, it creates two equal amounts. So 3x plus 6 equals 2x plus 8. Oh, I didn't do truth tables. Yeah, I can definitely do that. Let me just finish a couple more things from chapter 1. So know your complementary angles. So if 3x and 5x are complementary, you got to make sure you add them equal to 90. And then solve for x, plug it back in if you need. Supplementary angles, if those are the given, they have to add to 180. And then you could calculate for x, plug it back in. Know your distance formula. Know your midpoint formula. Know your circumference formula. Anything that's bold on your paper, your packet. So distance, we talked about in the very beginning. So the square root. So you subtract the x's, subtract the y's. Midpoint formula. That one you're adding, or you could do it in a logical way where you're just figuring out what is in the middle of the two numbers. Circumference formula for circles, so 2 pi r. Okay, that's basically chapter 1. Area is base times height. Okay, then let's do truth tables. We did not do truth tables. There are 3 of them you have to sort of memorize or have memorized. So here's or situation. Here's the and situation. And then here's the, I'm doing the general one and I'll do a harder one, okay? So we always want to build it by doing T, T, F, F, true, true, false, false. The next column is alternating, true, false, true, false. So for or, as long as you have one true in a row, then it's good. So since this row has one true, my final answer is true. The second row has at least one true, so it's true. Third one is true, but the last one there's no trues, so the final answer is false. For and, what's required is both are true, both. So in that case, there's only one scenario that has both true. So the first row, both are true. Final answer is true. Uh-oh, next one's no good. You needed both to be true. This is the bad one, so that's false. Okay, third one's no good, and fourth one is no good. Okay, the last one, last scenario, the basic one, I'll do a harder one after, is, oh, I gotta build it first. T, T, F, F, T, F, oh my gosh, T, F. So this is where I always set it as like there's a promise. So if you say something in the beginning, you must follow through. And this person did. This first scenario, they said they'll do something and they followed through, so it's true. I use the example, if I come home early, then you get ice cream. Okay, the second scenario is I came home early, so I made a promise, but I didn't follow through. This is false. You didn't get your ice cream. So I did not keep the promise. I did not follow through, therefore that's false. The third and fourth scenario is I never pinky swore anything. I didn't say anything, so anything goes. So I didn't come home early, but I gave you ice cream anyway. So I didn't break a promise because I didn't say anything in the very beginning. So I'm safe. And the last scenario is false, meaning I didn't say any promises, no pinky swear, and I didn't have to do anything. I didn't have to keep that promise, so it's still true. So I came home early. You didn't get your ice cream, but that's okay because the promise was if I did come home early, something would happen. So conditional means there's a condition, like you have to do something if you said something in the beginning. So here's a harder one, okay? Let's do a truth table for this combination. This is slightly different from the study guide. It's a little different. We're doing truth table. So step one, you got to build your basics, P and Q, and we always want to do what's in the parenthesis first. So let me just start building this. True, false, true, false. And so I need to build this one, whatever's on the left side of the arrow. So I'm going to build P and Q. This is and. So I just did the basic one right before this. This is where you have to have both to be true for it to be true. So the first one is the only one. Everything else is no good. It's both have to be true. Okay, then it's not required, but I recommend it. I recommend to draw another column of whatever's on the right side of the arrow. You're like, what? It's right here. I know, but it's good to have visually because then you're going to read left to right. Okay, so now in other words, this column is no use. This column is no use. You should focus your eyes on these two columns, right? So last but not least, now we have to say here's the left side and here's the right side. So here's the left side and here's the right side. So don't look at these anymore. Those are done, okay? Don't cross it out on your paper, but those are essentially done. You cover it up with your hand or another piece of paper. This is the if then, the promise that we just talked about. So I made a promise. It's true. I kept my promise. Therefore, this final result is true. The second scenario, I didn't make any promise and I just did it anyway. So I came home late, but you got your ice cream. Woo, bonus. So it's true. I didn't break a promise. That's the only goal we're looking at. Third one, I didn't say anything, no promise, no pinky swear, and I didn't do anything, so it didn't matter. So I came home late, you got no ice cream, it doesn't matter. No promise, no one was hurt. No one, was like, hey, where's my ice cream? And then the last one's the same exact thing. Oh my gosh, what is this called when it's all true? Starts with a T. It is a tautology. Exactly. That is right. Cool. Okay. So we didn't get to do every single thing, but I did hopefully get to answer a lot of your questions. The packet is golden. If you study the packet and check your answers tomorrow in class, you should be good to go. So once again, let me just explain Thursday or Friday, depending on what period you have math. You will have about 90 minutes, approximately 90 minutes. You'll have a 50 multiple choice, so 50 questions. And that's, I would say, pretty fast, like find the midpoint, find the distance, find the next term, what's the converse, what's the contrapositive. And then you'll have approximately 10 to 15-ish questions that are proof related, logic related, circuit related, everything that's on the front page of your packet. So on the packet, it should even explain it. The final is, I'm just reading it. The final is worth 2 parts, or the final is 2 parts worth 200 points. Part 1 is 50 multiple choice questions, which is worth 150 points. Part 2 is written answers, like fill in the blank. So just like the proofs that you see, the truth tables, the logic proof table, and some matching. Can I pass out candy? Can I pass out candy? Do we get to eat? Usually no. it's just distracting to eat during testing. And I know like other testing environments, they don't even know, some don't even allow water. Like I was like, whoa. But so I would advise probably try to eat like right before. You could ask your teacher if it's like a quiet snack, like nothing too loud, then maybe, like a sandwich, like a peanut butter sandwich or something, possibly. But if it's like Cheetos or like something crunchy, I think people will be like distracted and you'll start getting some stares because they'll be like, hey, I want some. So good luck, everyone. Let me just stop the recording. Let me put the link. And this